Okay, so let's go over how to solve equations that have variables on both sides involving word problems. So along the side, you can see the steps we're supposed to take whenever we are solving equations with word problems. We first need to define the variable. So I always like to skip to the question because that always tells me what my variable is going to be. So my variable is going to be the number that we're looking for. So now my goal is to set up an equation. So I need to read through the problem and translate it to a Matheny's equation. So it's telling me if 4 is subtracted from twice a number, so the number is going to be x, the result is 10 less than that number, which again is going to be x. So 4 is subtracted from twice a number. So twice a number then has 4 subtracted from it. 4 is subtracted from twice a number. The result, which is equals, is 10 less than the number. So we have to take the number and subtract it by 10. So this is our equation representing these words in Matheny's. So now I need to solve the equation. I don't have to distribute or combine like terms. I just have to get the variable to one side. So I'm going to subtract x because I like to get a positive coefficient. So that leaves me with x minus 4 equals negative 10. And then I just have to isolate x by adding 4 to both sides. So x equals negative 6. So our final answer is that the number we're looking for is negative 6. So for the next one, I'm going to jump to the question first. So the question says, in how many months will Bill and Phil weigh the same? So X, or in this case, M, is going to represent the number of months. So let's reread through the problem. Right now, Bill weighs 120 pounds and is gaining 12 pounds each month. So Bill is 120 and he's gaining 10 pounds each month. So the variable M goes with the 10 because M is representing months and 10 has to do with each month. The 120 doesn't get M because it has nothing to do with the months. Phil weighs 150 pounds and is gaining 4 pounds per month. We're looking for where are the two equal. So we want Bill to equal Phil. And now we're going to solve. So I don't have to distribute or combine like terms. So I'm going to subtract the 4m from both sides to give me 120 plus 6m equals 150. I need to get rid of the 120, so I subtract it from both sides. And then I need to get the 6 away from the m, so I'm going to divide both sides by 6. So m equals 5, and m was measuring months. So in 5 months, Bill and Phil will weigh the same. So jump to the question, how many letters L must be engraved for them to cost the same? So the questions are honestly telling me what my variable is. So L is my variable and it represents the number of letters. So at one store, a trophy costs $12.50 and engraving costs 40 cents per letter. So the cost of the trophy at this store is $12.50 plus 40 cents per letter. And then at another store, it's going to be $14.75 for the trophy with 25 cents per letter. And again, we want where the two stores are going to be the same to engrave. So we draw our line. I'm going to subtract 0.25L from both sides, which is going to give me 1250 plus 0.15L equals 1475. I'm going to subtract 1250, 0.15L equals 1.25. And then I'm going to divide, 2.25. I'm going to divide both sides by 0.15. And so there will be 15 letters engraved in order for the two trophies to cost the same. And so this last one says, after how many days will they have the same amount of money? So the variable is going to represent the number of days. So Perry has 140 and is saving 6 per day. Nick has no money, but I don't really need to write 0 in an equation. He's gaining 8 per day. That's all I need to write. So I'm going to subtract 60 and divide by 2. So it's going to take them 70 days to have the same amount of money.